So first I want to talk about the three trigonometric ratios. The first trigonometric ratio is sine, S-I-N-E. The second is cosine. And the third is tangent. All right, starting with sine. So the sine of an angle is equal to the length of the opposite side from that angle over the length of the hypotenuse. Let's look at a triangle and actually do an example with this and just set up our trigonometric ratio. All right, so with this right triangle that's given, we're just going to walk through an example of how to label the sine of the angle that's noted for us. So that top angle is the one that we're looking from. So if I'm looking from this angle, then the opposite side is the one that's directly across from the angle. So 3 is the opposite side. And the side that's directly across from the right angle is the hypotenuse. So 5 is the hypotenuse. Then to set up our trigonometric ratio, all we're going to write is that the sine of that angle is equal to 3 over 5. So sine, you'll see it abbreviated on your calculator as S-I-N. So sine of this angle, sometimes it'll be x, sometimes it'll be a different letter, sometimes it'll be the Greek letter theta. So I'm going to use theta for now. So the sine of that angle is equal to the opposite, which was 3, over the hypotenuse, which was 5. Let me make a note here that this angle, we're calling it theta because it's an unknown angle. We don't know what its measure is. So instead of writing a long sentence that tells us the side opposite from this angle is 3 and the side that's the hypotenuse of this triangle is 5, instead of writing all of that, we can just say sine of that angle is equal to 3 over 5. There is a shortcut to remember that if you want to set up the sine, that's the opposite over the hypotenuse. So to abbreviate this even further, just to make it a little easier to remember, sine is equal to the opposite over the hypotenuse. Our second trigonometric ratio is cosine. So the cosine of an angle is equal to the adjacent side over the hypotenuse. This time we are going to find the cosine of the angle that's noted. So again, I'm going to call this angle theta because we don't know what its measure is. And this time we're going to set up the cosine, or the abbreviation is COS, of angle theta is equal to the adjacent side. Now the adjacent side, remember, that's the side that is connected to the angle. And the side that's directly across from the 90 degree, again, that one is the hypotenuse. Okay, so we have that 5 is still the hypotenuse, but this time 4 is the adjacent. So the cosine of theta is equal to 4 over 5. There is a shortcut for this one as well, just an abbreviation to help you remember it, which is C for cosine is equal to adjacent over hypotenuse. Okay, so think about where we've been so far. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then we have one more combination that we haven't done yet. So we've done hypotenuse with the opposite, hypotenuse with the adjacent. We haven't used the adjacent and the opposite together. So tangent is going to be that last combination, opposite and adjacent. The tangent of an angle is equal to the opposite over the adjacent. So again, if we are using this top angle in the triangle, then we need to label the opposite adjacent sides. Okay, if we've got these same measurements, 3, 4, and 5, then directly across from the angle that's marked is going to be the opposite side. The side that is connected to the angle is the adjacent side. So those are the two that we are going to be looking at for the tangent ratio. Again, we are going to call this angle theta. So the tangent, or the tan, of theta is equal to the opposite, which is 3, over the adjacent, which is 4. And to abbreviate this a little bit more, tangent T is equal to opposite over adjacent. Whenever you're dealing with measurements of a right triangle, if you've got to use trigonometric ratios, I would always recommend writing this out on your paper so that you at least have something to go back to if you ever get stuck. So SOH is where we start. Sine is opposite over hypotenuse. CAH, cosine, is adjacent over hypotenuse. And TOA, tangent, is opposite over adjacent. This acronym will help you remember the different ratios. There are some other ways that you can remember them. So if you always just say them in order, sine, cosine, tangent, then there are some other things that you can say, some mnemonic devices to help you remember their order. So one that I learned when I was in school was Oscar had a heap of apples. Oscar had a heap of apples. As long as you say sine, cosine, tangent, you can always remember Oscar had a heap of apples. Another one, so that you don't forget that sine goes with OH, that cosine goes with AH. Another way that you can remember it is just to say, come up with an acronym or some kind of sentence and mnemonic device to help you remember SOHCAHTOA. There are lots of different mnemonic devices that you can look up. You can Google them. You could come up with one of your own. But this is the basis of trigonometry. It really is all about when you have a triangle, determine which angle you're looking from, and then label opposite, adjacent, and hypotenuse. And from there, you can set up your trig ratios. We have to figure out what information am I given. So from angle 41, okay, so from this angle, what information am I given in this triangle? Well, I know that I have the side that's labeled X is the opposite side from the 41-degree angle. I also know that 17 is the hypotenuse. So the information that I have is opposite and hypotenuse. Our opposite side is labeled X. Our hypotenuse is labeled 17. Well, opposite and hypotenuse, when I see that, I'm automatically going to think sine. Sine is opposite over hypotenuse. So I'm going to take what information I was given and just set up my trig ratio. Okay, well, we are looking at the sine of angle 41. So notice I'm not using theta anymore because I was given the degree measure of that angle. So the sine of angle 41 is the opposite, which is X, over the hypotenuse, which is 17. Well, how does this help me? If I know sine of 41 is X over 17, how does that help me find X? Well, notice what we have here. This is a trigonometric equation because we have an equal sign in there. So what I can do is solve this equation for X. Well, how can I do that? Okay, if I've got sine of 41 equals X over 17, then I want to start by isolating the X, so I need to get rid of the 17. So to do that, right now it's X divided by 17, so I'm going to use inverse operations to get rid of the 17. So the opposite of division is multiplication. Well, division by 17 and multiplication by 17 are inverses, so they cancel out. And we are left with 17 times the sine of 41 equals X. So now all I have to do is evaluate or see what is 17 times the sine of 41. So we're going to evaluate this in a calculator, or in this case, we're going to use Desmos. So in Desmos, and your handheld calculator, if it's a graphing calculator, it will have this feature where you can go to Functions, and notice that I have a Trig tab. So under Trig, I'm trying to find the sine of something. So I can press that sine button, and it'll let me type in 41. I don't want to just know sine of 41 though, I want to know 17 times that. So 17 times sine of 41. Now I want to point out that in Desmos you have two different modes, same with your graphing calculator. if you click the settings button up at the top, you'll see where I can toggle between radians, which gives me a negative number, and degrees, which gave me a positive number. So if I had this in radians and I get negative 2.6965, that long decimal number, if it's a negative, that doesn't make sense because we're talking about the length of something. The length of an object cannot be a negative number. So if you get a negative, or if you get a number that just doesn't look right and you're kind of concerned about why it doesn't look right, always check to see that you are in degree mode if you put in a degree angle measure. So our 41 degrees was a degree measure. It was not a radian measure. We haven't learned about radians yet. So if you have any kind of degree measure, that's what you're going to make sure that your mode is in. Okay, so we get that 17 times the sine of 41 is equal to the decimal number 11.15. We'll round to 2 decimal places. So that's our final answer. The side length x is 11.15. So that was our process for finding the side length of x. Now let's find the side length of, we'll call this side y. All right, well, if we're looking for side length y from angle 41, we have to consider what is the relationship between that angle and that side. Okay, well, side y is attached to angle 41, so it is adjacent to angle 41. So in this case, the information that we have is not concerning x anymore. It's only concerning y, and we know the length of the hypotenuse. So since we know the adjacent and we know the hypotenuse, we have to think about which trig ratio does that represent. Okay, so adjacent and hypotenuse is cosine CAH, which is cosine is adjacent over hypotenuse. Now we can set up that trigonometric equation. Okay, so the cosine of angle 41 is the adjacent side, which is y, over the hypotenuse, which is 17. Okay, so now we're going to use the same process to solve for y. All right, well, we want to get y by itself, so we need to multiply by 17 on both sides. So 17 being divided and 17 being multiplied are inverses, they cancel out, so we are left with 17 times cosine of 41 is y. And we can plug that right into Desmos to get the actual value of 17 times cosine 41. So 17 times, and then we'll go to functions, cosine, type in your angle measure, and we get 12.83. So 12.83 is equal to y.